So whenever we apply some machine learning test on any of the data set, first we need to understand about the columns. What column we do have and how do it will work according to the columns. So there are some columns which is duration, right? And intrusion detection system can be used to understand also the time complexity. If any of the network has a large network congestion, then it will also could be a sign of intrusion, right? So that also you can check whether it is it is having any kind of delays, yeah, time complexities or no, right? So there is a duration column, there is a protocol type, there is a service type, there is a flag type, SRC bytes, source byte, destination byte, how many data you have sourced from the source machine, and how many data is been reached at the destinations. So this you'll have to count, land and wrong fragment, urgent. So these are the columns by which we can understand about the intrusions, right? So these intrusion we can check, or many more data sets we do have to predicting all these things. So here I am using a kind of intrusion detection system. The data I do have already in my system, and I am using the platform I'm using for this is basically Google Colab, right? You can go there easily, and you can sign in with your Gmail account. This is the Google product, so you can easily use it, right, for writing the Python programs or not. And this file is called basically notebook file, right, where you have been given with the different cells, and in each cells you can write multi-line programs, and each cells can be executable, right? So this is the cell, and I have written 5 to 10 line programs, and just click over here. So this cell will be execute, and in the second, if you write another program with another cell, so you can make the another cell by clicking here plus code, and this is to write the text or the paragraphs if you want, right? So there are two kind of cells would be there, right? And each and every cells code cells can be executed, right? So here I am using the intrusion detection system with the help of some data sets, and that data sets I am taking from so so I'm taking the data sets from here, and I'm uploading it over there because it cannot access. This is a cloud-based ID, so you cannot directly access the files from your system. So we need to upload first over here. We have uploaded our training data sets. It has been uploaded. Now what we need to do is first, we have imported lots of libraries like operating system, pandas. Operating system doesn't need it because we are not using any operating system from our system. So that is that we don't use. Next is import pandas as PD. Pandas is a library of Python to fetch the data of any tabular format, right? Any table formats in any Excel format or any CSV format data. You can access the data and you can apply some functionality over that data. Then we have NumPy. This is used to work with the arrays. Matplotlib is to plotting the data. C1 is also used to plotting the data, and time is there to calculate the timing complexity. So there are some libraries which is importing over here, and you can just import it and run it, whether any of them is any problem or not. Sometimes some library has some problem, so you can detect it by running there. So if you run this program, so if you're not getting anything, means it's okay, right? So for successful execution, you'll got always a green tick mark, right? Second, we need not to run this. Third is we need to find out the column names, right? So these are the column names over here. So whatever the file I'm using here, that has a multiple columns, right? In the previously in the Kaggle, we have seen a data set that is different because there has only some few columns are there, but here we have lots of columns are there, which is duration, protocol type, services, flag, SRC bytes, DST destination bytes, land, wrong fragment, urgent, hot, num failed logins, right? And there are some thing is written over here, which is symbolic, continuous, continuous, symbolic. This means what kind of data which is inside it. Is it symbolic or continuous? Continuous means numeric. So if the data is numeric, so it will be always the column is always continuous. If the data which is in that column is symbolic or a kind of a string value or a kind of a text, so it will be written as symbolic. So there are lots of columns, and those columns, some of them are symbolic or some of them are continuous, right? So we just run it, and after running it, you can see that this file is basically here. Kiriris cup.names. This file is here. Third is okay. We are changing the name basically, right? We are changing the name over here. Each and every column has different name, but we are changing the name with the different names, right? And after that, we are opening a file. The file is training attack types, right? This is the text file, right? This is a text file which has the training attack types. This is actually the target file: backdos, buffer, FTP, right? Guess password, IMAP, IP sweep probe, land, right? Multi-hop, Neptune. This is a type of attacks. Right? Then attacks type, different attacks type are there: normal, back. So we are actually defining it by ourselves. Now reading the data set. So for reading the data set is here in the GZ format, and this is basically zip format, right? Where all of these data sets has been written, right? And you can read that data set by pandas, right? So this is the data sets which has all the values. There are 5 rows, and we are just taking that data into a variable which is called df, right? So df is basically data frame. Whenever we take the data, we read our data from any Excel format or any tabular format to the Python with the help of pandas, then it will be taken as a data frame. So this is the data frame, and this is the column names, right? And df.head means we are only fetching some data, like we are only fetching 5 data from our data. There are lots of data over here, and we are fetching only this. The total shape of the data is 494021. We have 4,94,000 data into it. The data set has that much row and 43 number of columns. Means we have 43 attributes or features, right? And we have 4,090, 94,021, right? So these are the data shapes. What is the target? Target is basically, it is according to the type of attacks, what kind of type of attacks we do have, and how many data we do have. according to that attacks. So Smurf have 2,80,000 data. In Neptune, we have 1 lakh data. In normal, we have 97,000 data. And one by one types, it has different data given, and their attack type is already given in the data set. So we are accessing it only. Right. DOS, normal, prop, RS. Yes, this is the attack type, and this is the target. What is the data types? We can check by data types. So by duration, we can check that it has integer data. Protocol has object type of data. This is a data type, which is a type of data which is into the column. Right. Most of them is integer, and some of them is float. Right. Some of them is object. Object is a kind of text type of data is object basically. Data pre-processing. First, we need to find out. We need to pre-process the data. For pre-processing, we need to have check whether there is null data or not. Right. For checking the null data, we have is null function, and if any column has any null data means if any cell is empty, if any cell is blank, it will tell you. So there is no any column has a null value. Right. Every cell is filled with some value. Means there is no any null value, we can apply it, because whenever if there be any kind of null values into the data, then we'll have to treat it first. Will have to process it first. Right. After processing, we can use it into our learning process. Otherwise, not, because some of the function doesn't use their functionality with the null values. So they'll deny it. They'll give you some error. So that's why we are not doing this. Okay. Finding categorical features. Those features which does have symbolic data. We are just finding those columns. So there are 3 columns which has that kind of. One is flag, prototype, protocol type, and services. Right. These are the data. These are the columns which have categorical feature. Categorical feature means string data is there. Right. So by this we are removing basically. Right. So if there are any categorical features are there, we are removing from our data sets. Categorical feature distributions. You can see that there are 3 type of features. In the protocol type. In the protocol type, we have 3 type of protocol. One is ICMP, TCP, and UDP. Right, and their countings. This is the counting values. Okay. Next is services. So there are lots of services in their graphs. Actually, we are analyzing each and every columns. What kind of information it does have, we can find out by analyzing the data. And this is bar graph of flag. These are the different flags we do have. Logged in. So either logged in or not logged in. Right. So there are 2 data, 0 and 1. Bar graph of target. So there are different targets. Targets is basically a kind of attacks. Is there a type of attacks? DOS, normal, prop. This is the column names. Next is data correlations. They'll check the correlation of different data. Right. So it will show you the correlation values of the data. Right. Like durations. According to the duration means it first check into the target. If there is some target and the target has correlated with the different targets, how it is correlated. That correlation we can plot by this, right? And this is a kind of metrics in the form of, we are giving a color palette over here, and according to the color palette, so basically it is what it is giving you. So if there is any correlations, that the value will be very light color, and if there is no any correlations, the value will be very darker. So these points where there is darker color, it means they that data is not actually having any correlations. They are not related to each other, right? If the data is lighter, means there is a correlation to each other. So depends, is there any negative value or any positive value, right? If there is any positive values, it will give you a kind of, uh, uh, if it is one, means it is more correlated to each other. So here is the point, but actually these points are why this is like this, because this is nothing. This is, it is duration is correlating with the same duration. That's why it is correlating and the value is one, right? And with the another data, we'll have to check with the another data, right? So same targets, whatever the targets we do have, we are correlating them to each other. Next is uh, some more columns are there, right? We are finding out the correlations, right? So where there is around one or one or around one, those are correlated to each other. So we can use those data for finding out, for analyzing, right? So these all data are actually correlated to each other. This is destination host same SRV rate and DST host SRV count. Those are correlated data. So we can check it out only. This is for checking only. This is nothing we are doing. We are just checking. Okay. So some of the data, some of the columns which is not correlated, which are not very, good feature for us to finding out the tags, then we are dropping those columns. We are deleting those columns by this. Right. So these are the columns by which we are deleting num root, SRV, server, because they are not correlated. So after dropping lots of column, we do have now we have 33 columns. Around 10 columns we have already dropped. Now the shape is this. These are the 33 columns we do have. Right. So this is basically what we are doing. We are processing it first. Whenever we use any data with any calculation, first we process it that our data is right or wrong. Right. If our data is informative or not. If not informative, we will not use into the process. Right. This is used to finding out the standard deviation, STD, and then protocol types, value count. Now there are three protocols: ICMP, TCP, and UDP, and this is the counting values of them. And we give them some value, right? We are mapping with those values. ICMP is given with 0, TCP is given with 1, and UDP is given with 2. So we are mapping these features with this data with 0, 1, and 2. Means we are giving a numerical value to them. And to whom we are actually giving them. So basically those data which is very correlated, but that is in the form of string, that is in the form of text, right? Actually what we are doing, we are calculating, but the calculation can be done with the numbers only, right? The problem is if any data which is very impactful in our data set, but it is in the form of string or in the form of text, we cannot process it with the numerical process. So that's why what we need to do is to convert into the numerical data. So that is what we are doing here. We are converting because this is very impactful column, right? Protocol type, and the flag type is also impactful because correlations is very high. Services, we are dropping the services. Now we have 32 features and 4094, 4,94,021 data. So this is how we are processing it first. Now it is done. The processing is done now. Okay. Second is now we have the data and we have already processed it. Now what we need to do is to uh, pass that data into a machine learning model so that model can understand that data and it can understand the patterns of data, right? And for that, what we have done first, we'll have to take a train test split. What it is doing basically in that data, we are just considering one data only, one data set only. What we are doing, we are just uh, finding the training data sets and test data set within this data set only. We are dividing this data set into two parts. We are splitting this data set into two parts. Some of the part of this same data set is taken as a training data set. Some of the data is of this data set is taken as test data sets, right? So what we are doing, we are just splitting the same data set into two parts. That is what train test split, right? And next is mean max scalar, right? And next is accuracy score. So first, we are going to import it. And for learning, we have a library. We have a package which is called sklearn, right? Machine learning, we have this package. By this, we can find out all the learning models with it. And this is used to check the accuracy score. Right. So it will show you, after train test split, uh, we did have this data, and after splitting, this much data comes with training, and this much data comes with the test after splitting, right? So 3,30,000 data will be taken as a training data set because we have given 30% data, 33% data will be taken as test size. So 3,30,000 data is be taken as a training data set, and 30% data, which is 1,63,000 data sets, data are taken as test data set. Right, that data is itself, splitted with two part, right? So that we can, train with the training data and we can test by the test data, right? And different models has been used over here, like Gaussian. Gaussian is nothing; it's a naive base, right? As I have already given you a kind of a naive based model. The naive base is basically a classification model. So this is model is used for the prediction. Then Gaussian NV is the class name, right? And we are fitting that data, training data, first into this, and we are finding the timing also, right? Training time. Second, we are checking the predicting time also. How much time it will take of predicting, how much time it will take for training, right? And what is the training score by putting this. So we have test score of 87% and we have a train score of 89%. Scoring is used to check how data is trained with this, right? So after the prediction, we have 80% of data is right and 13% data is not right. Means the prediction is all not good because every prediction cannot be 100% right. Right. 13% prediction is not right, and 87% is right. Means it again, it is a very good prediction. If it is finding a 87% of accuracy report, then it means the model is learning your data very well because we have a huge amount of data and it is learning very well. Only 13% data is not understandable by this model, right? So we have different models to predict it, and we can check which of the model is working well, that we need to find. So now we are working with the decision tree. Okay, so decision tree is taking time. Okay, and the prediction time is one, but okay, but the prediction is very good because the accuracy is 99%, right? If the accuracy is 99%, that means your data has read by this model in a very well manner. Only 1% data is not, predicting well. That means that is okay. 99% prediction is right. It means it's a very good model for this data. Same as with the random forest. What is the accuracy score? It is also having the same. Wow, it's so good. It's 0.999. There is only 1% error, 0.00001% error. Right. So that's a very good prediction accuracy over here. This is for the support vector machines. I'll provide this data to you. You can check it by yourself. I think it is taking a longer time. Okay, not to worry. It is already done before. You can see that this prediction is also good. But its timing is very large. I mean, if you go for this SVM, it is taking lots of time. The time complexity is very high in there. The logistic regression, you can stop it out. Right. So again, if we go for the logistic, so logistic is basically taking lots of time, 56 minutes, 56 seconds basically it is taking, right? Training time. The testing time is very less, and it is also having the good prediction scores. There is one more gradient boosting classifier that is taking lots of time. So actually, this time basically gives you how much data you do have and which model you will have to select for doing this, right? So first you need to check the training, and this is the artificial neural network, which again will take lots of time because here we are taking Keras system, and there is a neural network model is there, right? And it will take even lots of time, right? Its training time is very large, right? But accuracy score is this, and this is a training accuracy score. We can see that some of the we can see the data basically over here. Okay, so this is the basically name of our uh, models that we have applied. NB means naive Bayes, GT means decision tree, RF means random forest, SVM logistic regression, right? Gaussian based, and this is ANN. Gradient, sorry, this is gradient boosting. So there are basically lots of uh, model has been applied for one data, and we have seen it. So we can see that which one is the having the greatest, accuracy, right? So what it is actually checking is plotting names and values. Okay, this is a value of, I think, yes, this is a value of accuracy which has been taken, and we can see that which one having the same having the great accuracy score. So you can see that RF or 99.997, right? I think this one, two, three, four. One, two, three. Okay, RF random forest has a great accuracy score, and by this chart you can understand. Right, these all are the same level, but some of them is less, some of them. So both are right. Random forest and SVM, both are giving the best accuracy, and here this is the training accuracy, and here we have a test accuracy, test data accuracy, right? And next is this is the time taken, training time. So ANN is taking lots of time in the training, and for testing, SVM is taking lots of time, right? So these are the data. Basically, by this we can understand about the congestion, about the data types, and about the type of intrusion. And by this model, if the model is working, means any of the intrusion come here according to this data, it can understand, it can predict very well, right? And it will inform you according to that. Will the prediction model is done, now we can apply for the and will write the next code for updating you that yes, we have intrusion over here, right? So that can be done by this coding. So I'll send you this code, you just apply it, right? I'll send you the data sets also and the coding also. Okay, I think this is done to you all. Okay, now come to the next session of our uh, session. The next session is, I think, tools based something, right? The structure, infrastructures, and tools that we use for our sorry, it was done by mistake. Okay, let's proceed our next open source Internet of Things. Means open sources tools. What kind of open source tools we do have for working on all this? Because if you have you are working with the Internet of Things, we should have the hardware system for making embedded systems. Because with the help of embedded systems, we can only make the IoTs, right? Because the sensors will be stored. The sensors will be connected with any embedded system devices, and after taking that uh, data from the sensors, we can process it, we can analyze it, and send it to the cloud, right? And that can be only used by open sources, because open sources are those platforms which are free to you. You can directly download, or you can directly use it. There's no any there is no any charges you'll have to pay to them. So open sources, Internet of Things platforms, and what are the tools you can use. So we can see over here. The first of them is Node-RED. Node-RED is basically a kind of visual tools for lining the Internet of Things, wiring together hardware devices, APIs, and online services in the ways built in Node.js. Basically, it is working with the JavaScript node based open source we do have. A visual means for wiring the Internet of Things. It provides developer to connect device, services, and APIs using the browser-based Flow editor. It can run Raspberry Pi and further 60,000 modules on the accessible to increase its facilities. So first of all, a Node-RED, you can just click over there, and this is Node-RED. Node-RED website is here. Right? You can see there. There is flow editing, means there is a simulation based. You can simulate your devices over here. Built in Node.js is JavaScript node, right? Social deployment means you can deploy it on the website. You can make the codings. You can make the virtual hardwares here, right? So how do we use it? So by using it, you can have a device also. You can use the cloud also. And here, it is giving you a kind of a platform where you can make a virtual system first. You can make embedded system virtual. You can make the coding of JavaScript over here, and you can run it locally over here. And then you can run it on the device also, and you can use in the cloud also. So in the cloud, there are lots of cloud. It will be supportable. One is IBM, Amazon Web Services, Microsoft Azure, FlowForge. Which how many devices we can use it? So Raspberry Pi, BeagleBone, interacting with Arduino and Android, right? And run locally. We can use it in the Docker also, and we can use it in the local server also, right? Okay. So there are more platforms are there. Open Remote has also introduced a new open source IoT platform to create professional energy management, cloud management, or more generic specific management applications. Right. And here the protocols agents like HTTP, REST, MQTT to connect your IoT devices gateways. Right. Flow editor for the data processing, and when, then, and Groovy UI for event-based rules. Right. Next is standard dashboard is given to you for web UI components. Android and iOS console allows you to connect your phone services also. Right. Multi realms, multi-tenant solutions for the clouds also. Right. So this has been given for you for the open as using as a open source softwares for making all these applications. Next is Flutter. Flutter is basically a programmable processor code for electronic projects, right? Designed for students and engineers. Flutter take a glory it of long range. The Arduino based board includes wireless transmitter that can show up more than half miles. Plus, you don't require a router. Flutter boards can interact with each other quickly. Flutter has basically a processor. It has their own processor. Flutter is for one more thing. So this is used for making the applications also. It's used to making the applications also, and as well as it has a Flutter board also, right? Which is a processor, which is having their own processor. So you can use it, and you can integrate with the Flutter-based applications very easily. Right. Next is Arduino. If you are seeking to make a computer that can perceive and exercise stronger control over real world when related to ordinary standalone computer, the Arduino can be your wise preference. Right. So we have already seen that there are some Arduino boards which is made for IoT also, and which are without IoT also. If you don't want to implement IoT, they have given some kind of embedded boards. And if you want to implement some IoT applications, then they give some kind of Wi-Fi access to them, Bluetooth, and lots of things, so that you can connect it to the internet, ties to the cloud. Right. M2M Labs Spring is also the application framework for developing a machine-to-machine application, such as remote control, fleet administration, or smart terminal. Right. These are the application which is used for machine-to-machine. We can make this by M2M mainspring. Right. And it is based on Java. Basically, here we use generally Java and Apache. Right. Apache for databases. Right. Defined server, a pre-inbuilt server, which is coming from Apache, and there is a database used, NoSQL databases, right, which is for big data. Things board. Things board is for data collection, processing, visualization, and device management, right? And it upholds all standard IoT protocols like COAP and MQTT and HTTP as quickly as cloud and on-premises deployment. Means you can deploy your application at ThingsBoard itself, and it builds workflows based on design, lifecycle events, REST APIs events, RPC requests. Right. So if you go for the board, yeah, this is the Things board, open source IoT platform, device management, data collection, processing, and visualization for IoT solutions. So here you can find out the introductions, how it is working, right? And here you can write your data. You can add your rules. Rules is basically used to uh, write the constraints into it, as we write in the SQL. Microservices, and these are the products. First is Thingsboard Community Editions. Bring your ideas. And this is Thingsboard Cloud, and this is Professional Editions. Real-time IoT dashboard, right? As we have seen in, ThinkSpeak, the same thing is here, kind of. And we have IoT rule engine where we can connect our connections. How do we connect it? So here we can chain each and every elements which will be applied in the IoT, right, system. We can just connect it by only the chain, right? So there are rule changes are there. So this is the open source for making the IoT applications. Next is Kinoma. Marvel Semiconductor hardware prototyping platform involves three different type of open source. Kuma Create is DIY construction kit, prototyping electronic devices. Means it gives you a kind of kit which can be done by yourself. Right? And Kinoma Studio, it is like an Arduino. And Kinoma Studio is a development environment. Like Arduino has given you some IDs to write the program into it. So the same way, Kinoma has given you hardware also as well as the software also to write the program. And one is a platform which is called Ka. Ka is also a production-ready, flexible, multi-purpose middleware platform for establishing end-to-end solutions. Connected applications such as smart devices, it gives you comprehensive way to carrying out effective communication, deals with it, and interoperation capabilities in connect with intelligent devices. Right? The same thing is over here. Next is siteware, right? Here we have Apache Tomcat, and it runs on Apache Tomcat and provides highly tuned MongoDB and HB implementation for databases. Right? You can deploy siteware anywhere to the cloud platform like AWS, Azure, GCP, or an premises. On premises, it has their own cloud, and it also supports Kubernetes and cluster provisioning. And it can connect with the different protocols of IoT, which is MQTT, Storm, AMQP, and other protocols. Right. Next is DSA, distributed service architecture is there. Also, it's one is Thinger. Thinger is also a kind of a cloud-based connecting device. You can deal it with quickly by running the admin console or combining them into the project. So it provides you a kind of a cloud like your ThinkSpeak. WSN is also the same thing, and Particle is also the same thing. Next is Webinos. Next is Device Hive. Next is BeagleBone Board. Device Hub is there. Open Remote. So there are lots of open sources are there, right? One of them is Blink also. Blink is basically a kind of data management, data for the data analysis and machine learning functionality. So most of them is very popular. Like Blink is very popular in IoT systems because it gives you an Android and iOS app, right? They have their own app, Blink app, where you can write your data, which is collected from any IoT devices. So by for analyzing them, for taking a prediction, we have different tools into it in Blink, right? And in the Blink app, you can directly write the drag and drop system is over there. There is no very much, programming is needed to making this applications. Blink comes with a free developer plan intended to personal use IoT engineers. Allows you to add up 5 IoT devices for free. Right, so 5 devices you can add up into Blink. Thinger we have already done. And then the last one is Firebase. Firebase is a service issued by Google for the convenience of application developer to develop their application. Firebase is a solution offered by Google to make it easier for developer. So whatever the application you do have, if you need a kind of a database system, so Firebase, you can use a Firebase where you can store your data, and it's a database cloud where we can store our data, from where we can control it also, right? So it gives you the Google Analytics, it gives you the real-time database, it gives you authentications, it gives you the hosting. right? You can host your applications also into the Firebase. So these are some features of Firebase and all of sources which will give given to us, right? So mm, in these open sources, you can use any one of them or any two of them according to their conveniency. You'll just have to read about it, right? We have already seen that we had having ThinkSpeak. We can use Firebase also. We can use Thinger also. We can use Blink also. I'm sorry. So by these by this document you can have idea that what kind of source you need, what kind of uh, applications you need in your projects, right? Do you need any analysis, do you need any kind of learning or not, right? Accordingly you can choose any open source from there and you can use it very well. Okay. So now we are taking a 5 minutes break and then we start with the Arduino programming. Okay. Okay, can we start? Hello.
Yes, sir.
Yes, sir, you can start.
Okay, fine. So now we are going to start about Arduino programming, right? So first of all, whatever the application we are making is basically based on embedded system first. So if we want to make any system which collects the data from the different sensors, we need any hardware which is made of microprocessor or microcontrollers, right? So Arduino, which is a microcontroller based device. Arduino is microcontroller based device, and one is Raspberry Pi, is microprocessor based device. So in Arduino, what inside the microcontroller. So Arduino is a microcontroller based device, means a microcontroller is used on this Arduino. So Arduino is a company basically which makes this kind of devices. We'll go for Arduino, and it has a official website, arduino.cc. There you can find out the hardwares. So they are making lots of hardwares for different purposes, from tiny to very large kind of, and they have very heavy applications. Right. This is Arduino starter kit. Right. These are the hardwares they make basically. IDE. IDE is basically integrated development environment to write your coding into it, and we can prefer application of programming we want to write. We can program in this IDE software. IDE means only a software you are given, right? Which is Arduino IDE they have given. So there you can write any programs in it, and this is made for Windows, Linux, and Mac. Right? You can use it any of the operating system. Okay. Next, Raspberry Pi. I think it's a microprocessor based device. Microcontroller is a kind of device, kind of system where you can write only one program. If a specific kind of, so only one task it can perform. Microcontroller is very specific about its task, right? It'll use a single task which is given to you, right? So they can perform only one task which is given. If you are going to the Raspberry Pi is microprocessor based device. What is the mean of microprocessor? So it is a kind of a device. Controller is also a chip. Microprocessor is also a chip. Both are chip, but microprocessor is used to take the logics from the different controllers to process them. It is only the processor, right? And it processes the data. It only take the data from the different and that logic is processed with it, and you get the output by the processing, right? But micro particular task. So whenever you have to make a device which perform any task, that you can make always with a microcontroller. When multiple tasks has to be processed, then you'll have to use a microprocessor. Right. So Raspberry Pi is basically kind of a microprocessor based device. So it is kind of a computer. Right. Raspberry Pi is nothing, it's a computer. And Arduino is not actually a computer. It is holds a system inside it. Right. So we can program the microcontroller, but we cannot program the processor. We can only program with the help of any controller. We can program microprocessor, but not directly. We always use any microcontroller to send the data from microcontroller to that processor. The processor only process the data, right? We are not providing any kind of programming to them, right? We are not giving any kind of logic to them, right? So Raspberry Pi is like this. I'm giving a look about Raspberry Pi. This is a Raspberry Pi device. It's a kind of Raspberry device, right? So it is nothing. It's a whole computer. You can replace your computer with this small device. It's a very small device, not very large, and it is full CPU. And in between there is a processor. There are some USB is also there. 4 USBs are there. One LAN supportable peripheral are there, and one powers for the power supply. There are some pins are there where we can connect our low level input output peripheral like sensors, any RFIDs. We can connect it over here, and this is for the connecting any display devices. This is also what you call it, HDMI port, right? So this is mini HDMI port, right? So this is for connecting any devices which resolution is of 4K. right? So mini HDMI is that type of protocol where we can connect 4K graphical data. Right. So here in by this Raspberry Pi, this the version of Raspberry Pi is 4, and in Raspberry Pi 4 we can connect any 4K displays. Right. So there are lots of versions of them, like we have in the right. And we go for an Arduino Nano is very tiny device which doesn't have more pins. Right. So for the limited devices, for the limited sensors, we used to have this Arduino Nano. Right. If you want to make some small application, we can use it. And for larger, then we can use Arduino Uno. And for more connection peripherals, we can use Arduino Mega. Right. Generally, we have three versions, and in this, they are giving you some extra shields with it. Like some of the Arduino Nano is connected with Wi-Fi, right? So any Wi-Fi devices is inbuilt with it. Some of the Arduino Nano is connected with Bluetooth, right? Some of them is connected with GPS. So there are different peripherals which is inbuilt with it, and there are only three kinds of board you will get: Arduino Nano, Arduino Uno, and Arduino Mega with the Arduino. And with the Raspberry Pi, there are different Raspberry Pi versions are there. Raspberry Pi version 0, Pi 0, Pi 1, right? Pi 2 and Pi 3 and Pi 4. They have upgraded their versions according to their numbers. They have different facilities also. Raspberry Pi 2, Raspberry Pi 3, and Raspberry Pi 4. Now, Raspberry Pi 4 is the latest version. Right? Now we have the Raspberry Pi, which is the latest version of Raspberry. So the thing is, what actually you want to make, right? You want to process something, you can make an IoT application in both the way. In the larger scale also, like you want to implement some AI, right? In your IoT, you'll always use Raspberry Pi because it's a processor based. So multiple peripherals can be used with this. Like I want to use a camera. I want to use some mic with it. I want to use a kind of lots of images we do have, right? So for convenient use, we always apply apply IoT and AI into Raspberry Pi because Raspberry Pi is fully computer. It is working as a computer. You need a mouse, you need a keyboard, you need operating system. We need a graphical monitor for it, right? So it has everything, right? So Raspberry Pi can be used for that application when we want to implement any kind of AI implementation on our IoT devices. If we need some a small kind of devices which doesn't have any kind of AI applications or not, then we can easily implement it with Arduino, where we have only some data from the sensor and we want to store it into the cloud. We can directly use it Arduino, or any Nano or any Giga with that peripherals with the Wi-Fi device, because Wi-Fi is used to connect any routers which is nearby to you, gives you the connection. And this device, you can make the device as a network, as a wireless network, and then given to the cloud. Right. Okay. So Arduino will have some kind of the program into this IDE. What is the prerequisite? The prerequisite is one language you should know. Any programming language like C or C++. For Arduino, it is based upon the programming is based upon C or C++. So either you know C or C++, you can easily write the Python. So there are different programming languages for that kind of devices. So here we need C and C. Let's use C and C++. And for Raspberry Pi, we need to use Python. So Python is a programming language that we use with the Raspberry Pi for writing the script, programming script. And for writing the programming script in Arduino, we use C and C++. Okay. Okay. So first of all, this is the ID where we can write our program. Programs you always have to take a kind of the Wi-Fi device into it. As you can see that most of the hardware which is having Wi-Fi connected to it can be used as a IoT device. The shield, yes. Arduino Uno with the Wi-Fi, right? And it's connected with the shield. Okay. So let's check it out. So the device over here, BLOX is there. So this is actually the Wi-Fi device, which is integrated over here, right? And sometimes it is known by ESP. I don't think it is written over here. It is kind of a ESP device is there. So the name of Wi-Fi device is ESP. Maybe we can find it out. The Wi-Fi name. No, nowhere is written any. Okay, fine. So basically the name of Wi-Fi device is ESP8266. The Wi-Fi device, right? So these has, you can see that there is written Wi-Fi. Okay, it means it can be used for the data to collect from this device, and we can connect it to any Wi-Fi router so that we can send it to any cloud. Right. For that we need a Wi-Fi device. We can connect the internet all Ethernet also, but Ethernet is not it's a wire kind of connections. If you use Ethernet, it means you'll always have to put the wires with it, right? Ethernet wire, which is called LAN wires also, right? You always have to connect with the LAN wires. But Wi-Fi is easy available and it can be portable also. If you connect any Ethernet wire in the Ethernet devices, we cannot port it to the anywhere. And the thing is, Wi-Fi devices are more portable, more good to use, right? So we generally use Wi-Fi devices. That's why. Okay. So in the Arduino, for the IoT purposes, we need that kind of Arduino device which has ESP8266 shield. ESP8266 Wi-Fi devices are inbuilt over there. That kind of devices we need. So I do have that kind of device, right? So for that, what you need to do is first when you use any Wi-Fi devices, ESP8266, you'll have to write some over preferences. First, you will have to download what we have over here in the ID. I tell you some overviews. So we have a tool section. In the tool section, we have basically a board names which is go to the preferences, and then in the preferences you'll have to write uh, you know this link. Right, this is the link which is Arduino.esp8266. This is the board link where we can download the ESP boards over here because we need to have that kind of list. Otherwise, we cannot use that board. Right. So this link you'll have to write over here so that it will pick that board from this link. Right. This is the board link over here, and just write the OK. And after that, we'll have to go there, and in the tools we'll have board, and in board we have board managers. And after clicking the managers, what you need to do, you have this window, and you'll have to write it ESP8266 to search out the ESP boards. So here the ESP boards has been searched, and you'll have to install it. I have already installed, and there is an installation button over there. If you'll search it, then you will have to install it first. After installation, what you can do is, and that is done, right? Now, so this is the program we have written yesterday, right? What is in the program? So first of all, the program is for connecting the for connecting with the router which is nearby to you, right? By which you can access the internet. So this is the router I do have. The router name is the connection name is Ducat, and this is the name of but this is the password, right? And this is the server name we'll have to access. We can write the server name also, right? So the server name, when you want to try to access any server, right? And we are trying to access the servers with API keys because it's a cloud only, right? So it's a cloud. If it is a cloud only, they are giving you some kind of API keys so that we can connect with that APIs, and we can store our data to that cloud, right? And we can read the data from that cloud also. So when we use that ThinkSpeak, as we have already done yesterday, there was a ThinkSpeak, and in ThinkSpeak, we had two kinds of APIs will given. One is of for the read. Yes, it is signed in already. Okay, just go to the channel first. So which channel we were accessing for IoT? I think this was the channel we were accessing, and the data we have posted over here is, you can see it over here, and the API keys we have been given a kind of write API keys and the read API keys, right? So write API keys is used to write the data, and read API keys is to read the data from there. If any data which is already stored with that API over there, and we want to read it, so that read API keys is different, and for the writing our data to that cloud is different. So if we will have some data. Okay, fine. So if we need to read the data from this API, from this application, from this cloud, so we need to access this read APIs. And if we need to write some data which is collected from our IoT Arduino devices, so we can apply the write key that we have already given over here. So this is the API key that we have given first, right? And for transferring our data from the Arduino to that cloud, we always need that API, right? So that is why we have already written over here and made a variable for that. Okay, and for accessing the uh, functions of all, for the networking, we need a kind of header files, as we have as I have already given you an idea about that. This is on the base of C and C++, right? The software or the programming we are doing on the base of C and C++, and in C and C++, we always include some header files for accessing some predefined functions. So here we are accessing a ESP8266 Wi-Fi.h. It's a header file for accessing a function for ESP8266 for the Wi-Fi operations, right? And there is one more header file is included, which is DHT. That is a temperature sensor header files that you also apply over here, so that we can take the data from temperature sensors. And the temperature sensor we are using over here is DHT. The name is DHT, right? So here is DHT11 sensors is used to read the temperature at in-house temperature data and the humidity data. Right. So this temperature sensor we are using over here for reading out the data of in-house. Right. So these two header files we have been including, and next is API keys, which should be needed for communicating with the cloud. And this is the SSID. SSID means that network name that you are using for your router, and the password you need it for that connection. And one is the server. So these three variables we have been already declared over here and given the data to it. Right. Next is DHT pin, means where from which pin DHT has given you the data. So by D1 pin, D1 is basically the data one pin of your hardware, of your Arduino, right? So D1 is the hardware pin of your Arduino, from where you are reading the data from the temperature sensor, right? So this is the DHT pin, and you'll have to access a class. This is the class name, and this is the object name. DHT is the object, and this is the class we are accessing. And in the class, what we are sending, there are two argument values we are sending. One is DHT pin, which pin from where we are getting the data, right? And what kind of DHT we do have, because we do have different DHT sensors like DHT11, DHT22 also, right? We can have DHT22 also. So first you write the sensor name, which DHT you will be applying. So DHT 11 is here. I'm applying only DHT 11. That's why we'll have to write over here the sensor name. The sensor name is DHT 11, and which pin it is connected to, that we need to pass it. Right, and this is the object we have made for this class, and then we'll have to make one more object for the client, right, which client is to be accessed. So server name is there, server is ThinkSpeak, and the client name is client. Okay, so one more thing, there are two functions to be given by Arduino when you make any file, any of the file. When, let's say, I have made any new sketch. So in this sketch, what happens? It will give you two functions by default. Nothing has been written into it, but it's a two kind of functions. One is setup and one is loop. It's universal. So in Arduino, there two functions is always given. First, in setup, what you can write? In setup, you can write the settings. What is the setting you'll have to perform before writing your data or before processing your data? So before processing data, what kind of settings you needed that can be written in this setup functions. And in loop, we can write the process, what kind of processing we want, so that we can write in the loop. Right. So two kinds of functions are there, and both the functions have different works. Right. And here, first of all, we are writing serial.begin. Serial.begin is for the serial communication, by which we can write our data with the serial, baud rate. This is a baud rate, right? So this function is used for the serial communication, and we can, whatever the serial communication we are writing to the, because the Wi-Fi connection is based on the serial communication. Right, whatever the router we are communicating with the Wi-Fi devices, it's basically a serial communication. If it is the serial communication, we need to write the serial functions. We need to call the serial functions from here. So serial, first we need to start the serial communication with begin, and the baud rate. This I have written the baud rate, right? And this is the delay. And now DHT begin. DHT begin is for connecting the DHT, right? And serial begin is for connecting the serial communication. Serial.println, it is written connecting to, you can see it at the serial monitor. Here you have been given a serial monitor for showing they show the messages of the serial communication here. Have not connected any kind of board with this. That's why it is written, a message written over here that not connected any board. Right. As I have I'll connect, then it will automatically connect it. Okay. So here, yes. So serial println means to print the messages, whether our connection has been done or not. Because in the setting, what we can do, what settings we will apply. So first setting is that we'll have to set the connections of our devices to the Wi-Fi, which Wi-Fi we want to use, from where, which routers we want to use, so that our data would be started or created at the IoT devices and send it to the cloud. So that device and that cloud would be connected with internet connections. How? By the router. So by the router, so we have given the SSID, which is the router connection or a network name, and the password, so that we can connect to that router. Okay. So here we are passing it Wi-Fi for beginning the Wi-Fi. We are passing the SSID name and the password name, which has been written over here already. You can apply yours, whatever the router name or the network name you do have. Right. I'll give you this code also. Don't worry about that. And next is status. So even it is working or not, it is connecting or not, we need to find out the status. And until it is not connected, you will find a dot, right? It is a kind of this is the loop which is written. Loop is until it is not connected, right? So you'll be showing a dot with it. That's why it is written serial.print is dot. And if it is connected, then this loop will be terminated and is coming to this line, and this line like Wi-Fi connected. Okay, so this is for settings. So what we are setting over here? We are setting how your device will connect to the internet, right? So that's why we have written it with the setup. Now to the loop. Now after setting the loop, this is the once. What you do? You actually, whenever you set up any connection, you'll do it for once, right? So after connection, you'll do not do anything, right? I have, let's say I have to connect any network. So I'll write the password. I'll write the connection name, whatever the security has been needed. I'll write only once, right? Not every time. But the thing we need to write, we need to do is been repeatedly working. So that should be written in the loop function. Okay. In the loop function, what we have, we can read humidity data and we can read the temperature data from that particular object and that particular function name. In that class, two functions are already there, which is read humidity and read temperature. So by this functions, we can read the data from of humidity and the temperature from that DHT11 sensor, right? And both are storing into humidity and temperature. Then we'll just write in a script that if there is no values, let's say sometime we are writing it, but if no, your sensor is not right or any other condition would happen that your DHT is not connected properly, your DHT is not there, what it will give you? None value. It will give you the null value. So if there is null values with humidity and temperature both, then it is failed to read and write. Right. So fail to read from DHT sensor, the message will be given to at this serial monitor over here. This is the serial monitor. And if the client is connected, if everything is done and the client is connected, now the API has to be written in particular, link. So what it is there? So post update, this is host name, connection name, right? ThingSpeak API, content type, you'll write it, content length, right? Post str length means this is the post str which string you need to post. So basically that depends upon this one. Where this is coming from, basically, this is coming from here. Right? You can say this is the right channel feed. Right? And here we have written from here to here. So what is this? This is the basically the server name, right? That we are accessing with. So this is the server name, and this is the API key update, and this field and field one, field two may be there. More than one field can be there. So this is written like this. First is API key and field one, right, and field two, and this and this. Right. So this you'll have to write for giving the data according to the link they have posted, because that cloud has take the data from your side by some specific link they have given you. Right. You cannot directly write anything to that server, anything to that cloud, because they have given you some kind of. So this cloud has given you some link. By this link you can apply. By this link you can only give the data. If this link is not given to you, then you can, because this link is only readable by this cloud. It is not readable by any of others, right? Even if you write the different server name, they cannot understand about this API. They cannot understand about the field, because this is only special for this cloud. So they have given you right feed, right channel feed. How do you write it? They already given you that channel feed, right? So the same way you'll write over here, whatever given to you, and then temperature and humidity values, you can print it on the serial. This is printed on the client, not on the servers, not on the serial, right? And after sending, then client should be stopped. Then again you'll have to fetch the data again, and this is working repeatedly. This all of things are repeatedly working, right, with 1 second only, right? You can change it with the 10 seconds if you need some kind of data in 10 seconds, you can write it 1000 to 10,000. So ThinkSpeak need minimum 15-second delay between updates. Right? It is written here, but yesterday when we were doing it, so it was taken, I think, half an hour. Right? So half an hour has been taken by this. So we can run it again for you. So here you can see that yes, the program is already done. There is program. I haven't uploaded that program again because it has all the things. It has already connected to the with the network which has been written over it, and the data is been started writing. But it will take time to update over here. So as this cloud has been used, mm, it is taking time. This 22 hours ago it has updated. So where when is the last entry you can find over there? When your account has been created or channel has been created over here, entries, how many entries were there? There were 15 entries yesterday. We have applied 15 entries. So it is taking time. Okay. So this is how we can implement Arduino. You need to have, understand about the hardware first, and then how to write. And first of all, and out of all, you need to understand about the programming. Right? That is must. Right. So if you know the programming of C and C++ or Python, you can write any of the script with the Arduino board and the Raspberry Pi board. Okay. So this is all done from my side. If you have any queries, you can ask me.
Participants, if you have any query, you can ask. You can ask your query.
Okay. Ma'am, can we take group photo?
Yes, sir. Yes, sir.
All
Fine.
participants are requested to please switch on your videos. All participants, please switch on your videos.
I need to reconnect.
Yes, sir. One minute. Ha, ready? Okay, it's done. Thank you, dear participants. Thank you, Ritesh sir.
Thank you, sir.
Thank you so much, sir. Thank you all of you for joining today's session.
Yes, yes.
Ritesh, sir,
Thank you,
today's session
ma'am.
was
Yes,
really interesting. All the
yes, yes.
implementation part, whatever you have shown. Okay. Thank you so much, all of
Yes,
you.
yes. It was really interesting. Yes.
Ritesh sir, I have a question to ask.
Okay, yes, please.
Hello.
Yes, ma'am, please. Say.
Sir,
Yes.
suppose I have connected a sensor to a Arduino
Mhm.
and now I'll receive the sensor data on the serial port of Arduino, correct?
Okay.
Hello.
Yes, 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 please.
Now, from serial port where I will receive the sensor data, I
Mhm.
want to take it to ThinkSpeak.
Mhm.
How do I do that, sir?
First of all, the sensor that we are implementing today is not connected with any serial port, right? It is
Huh.
connected
Today we
with
were
the
working with
GPIO board.
ESP. Yeah, today we
It is
were
connected with
working with
GPIO board.
ESP. Yeah, suppose I am working with Arduino.
Mhm.
So ESP32 has a Wi-Fi connectivity, and that is the reason you could directly show it that I am connecting it to ThinkSpeak.
Right, right.
But now I have only Arduino with me, and I
Mhm.
want to take it to ThinkSpeak. So what
Okay.
is the middleware that I have to use to
Okay.
capture the
There.
data? Yeah,
Okay.
to capture the data and then take it to ThinkSpeak.
Right, right. So there is one more device is there, which is called ESP2. Sorry,
Okay.
ESP1, not ESP2.
Okay.
It's ESP01. It's a kind of a small, tiny device which is working with Arduino directly, which is not having any ESP inside it. Let's say I have an Arduino which doesn't have any functionality of Wi-Fi, right? So
Mm.
if I need to use any kind of Wi-Fi device, we could have a ESP01.
So
There,
that ESP01 needs to be interfaced with the
right,
Arduino,
right,
is it?
of course, right. So this
And
can
that
be, that is a very tiny device, and this can be implemented with the you'll have to connect it with the Arduino with the GPIO pins.
okay.
Then you can connect the modems with this system.
Okay. And suppose I want to take it as a CSV data.
Like this.
Okay.
This is the right.
Yeah.
Yes, ma'am.
Yeah. And suppose I want to take it as a CSV data.
Mhm.
The serial port data, I want to take it as a CSV data for data analysis on my PC itself, on my network itself. So then
Mhm.
what will be the middle tool?
So there'll be some softwares, there'll be some libraries which will help you to take the data from CSV to your data types which is working with C and C++.
Okay.
There is some library which will be helping you.
Okay. I used Teraterm terminal, but
Mhm.
that is taking for some slots.
Mhm.
Then again, you will have to refresh it to load the next set of data on the CSV. So there is some form of delay. So I
Mhm.
wanted to know if we have some tool where that delay is, you can reduce on that delay part.
Okay. What software you are
I
using?
use Teraterm terminal, sir.
Okay,
Teraterm
Teraterm.
terminal.
Okay, fine.
Yeah. That helps you to capture the serial port data.
Mhm. I understand that. One more is there. I don't know. I do have or not. What is the name of that terminal? Was no, there is a terminal I forgot.
There are two important ones. Even I am forgetting the other one. But
Yes,
there
yes,
is
yes.
one more that is also very frequently used.
Mhm.
If you have some notes about
Yeah, I'll send you that kind of software name also, right, to the ma'am, and their notes also, right,
okay,
and send you the link where you can download it. Right,
okay,
I
sir.
have already used it, but it's not in my PC right now, and I've forgotten the name
Yeah, not a problem, sir. And one more thing, sir. One last question, sir.
Mhm.
The list of IoT platforms that you showed, the PDF document that you showed, na sir, it had some IoT platforms, few of the very important IoT platforms.
Mhm.
Do you have any PDF document where there are some good number of examples to show us or to help us work on those platforms?
Mm, so each and every platforms you
No,
need
no,
to
any one or
any one of
two,
those.
any one or two, because
Okay,
ThinkSpeak is the
I'll
most commonly used. So
yeah,
everybody
ThinkSpeak
uses
and
ThinkSpeak. Yeah,
Firebase, ThinkSpeak. It's very
yeah, these
common.
are very common and everybody uses. But then the other one, Red a
Yeah, of
Node
course.
that you showed, the first one,
Right,
those
right.
are little uncommon, so we don't find good amount of documentation or YouTube videos on those two platforms, two or three platforms.
Right.
So if you have some good notes or illustrations which will help us to put our hands into the system and then learn it.
Sure, sure, sure. Sure, I'll give you some different which is not commonly used
Yeah,
platform.
yeah,
Right,
yeah.
I'll send you some PDF so that you can find a help from us.
ठीक है sir, thank you so much sir.
Hello,
Yes,
Ritesh sir. Ritesh sir.
yes, yes, yes,
Hi, I
sir.
have a question.
Yes, sir.
Regarding intelligent traffic control, I am going to ask.
Yes, sir.
Sir, suppose we want to control the traffic
Right,
between the two consequent intersections.
right.
In that case, how ESP32 LoRa will be helpful, and up to what extent it can help us
Uh,
regarding managing the traffic.
Managing the traffic, LoRa is basically that kind of Wi-Fi system where the network extend to the multi kilometers, right? So it doesn't need some kind of internet connection to sending your data from one place to another place. So if you are using any kind of a LoRa modems, so it will send your data from this some source A destination to B destinations, which is apart from 2 kilometers or 3 kilometers itself. So that we can use in a very major ways, right? In the area which is around 2 or 3 kilometers or around 5 kilometers, that can be managed by that connections very easily, right? So if you
Acha,
go,
हाँ,
if
हाँ.
you yes, you if you go for the LoRa, so LoRa has a very extensive Wi-Fi connections. So you don't need any internet connection with that because it has all the areas covered with it,
Hmm.
right? So that you can implement with any of the Raspberry Pi system, and in Raspberry Pi system you can manage it very well by connecting by writing a script of machine learning and AI, right? So that all the cameras which is fitted to each and every traffic light systems can be captured by that script, and that could be analyzed over there in the AI models, and then gives you the right decision to each and every traffic controllers, so that you
Yes,
can do
sir.
it.
Yes, sir. Thank you very much, sir. Ma'am, please. Prachiti, ma'am. Thank you very much, Ritesh sir, for your technical insights,
Thank you, sir.
deep way through the points. Really, it was very understanding session, and we got in face with all the details which are hidden, and you put it in front of us. Thank you very much, sir.
Thank you everyone for attending the sessions.
Thank you. So I think we all should leave now. Closing the yes, sir. Closing the